Hi, this is Tanga Kasirajan. Today we are going to see tensile test on mild steel using universal testing machine. It's a virtual lab demonstration. Before we starting the experiment, let me cover what is the stress strain curve, what is UTM machine, and how the behavior of ductile material. And this is the UTM machine. It's a computerized UTM machine. It consists of two jaws. One is upper jaw and another one is lower jaw. One jaw is movable. Here we have dial indicators to measure the extension of the rod. Load is applied using hydraulic power, and this is the standard specimen, ductile specimen. Today we are going to use mild steel, and this is the stress strain diagram for a ductile material. uh, this one end is fixed in the upper jaw and another end is fixed at the lower jaw. When we started loading, that is when we apply a load of F1, you have a small increase in strain. This x-axis represents the strain and y-axis represents the stress force divided by area. uh, so up to a yield point, it is observed that the stress and the strain are proportional to each other, and beyond the point yield, that is here the point yield, that is the it is converted from elastic to plastic region. Beyond further increase this yield point, you have a increase. It is observed that the strain rate is increased. The strain rate is increased, and further addition of the load forms a neck. So that shows the ultimate point, and beyond this ultimate point, the the specimen breaks. Actually, the breakage is shown in the figure. The breakage is just like a cup and cone fracture. So that represents the ductile material. So let me explain the same stress strain curve here. So up to the this is the point A is the proportionality point and B is the yield point. Up to the point A, the stress is proportional to the strain, and further increase in small addition of load causes the material to yield. That is, it transforms plastic elastic region to plastic region. So beyond B, there is a small increase in strain, and after this point C, strain harden happens. So after that, the formation of neck, and finally the specimen uh, failure failure occurs, and beyond this point D, failure occurs, and the ultimate stress is the stress corresponding to the maximum load taken by the specimen, and strain hardening is the point between the lower yield point and the ultimate stress. During this strain hardening, the material will undergo larger deformation. That is, more strain rate was observed during the strain hardened region. Let me go to the experimental part. So just log in on this virtual lab from Suratkal. Uh, so this is the theory part. This theory part I have already covered. Here we have formulas. That is, percentage elongation is equal to final length minus initial length divided by initial length into 100 represents the percentage. And similarly, percentage reduction in area is initial area minus final area divided by initial area, and the tensile strength is the ultimate load divided by initial area. So result should be in megapascal, and yield strength represents yield stress is equal to yield load divided by area, initial area, and modulus of elasticity or Young's modulus. E represents the slope of the curve, stress strain curve. That is a slope into gauge length divided by AI. We can also find the modulus of elasticity by applying the Hooke's law, that is stress by strain equal to modulus of elasticity, that is within this its elastic limit. So let me go to the simulator. This is the simulator tensile test apparatus. Here you have a load indicator. Here you fix the extension meter and the dial indicators for measuring the extension of the mild steel specimen, and use linear scale and vernier caliper for measuring the dimensions of the extension. So here you have two buttons. One is green color, which when you press the green color, the loading on the specimen begins. So red color represents the stop. So step 1, before you conduct the experiment, measure the initial diameter of the specimen in two ways. So measure the diameter. So the diameter, initial diameter represents 12.9 mm, and take the linear scale and measure the gauge length, and the gauge length represents 192 mm, and mark several punches on the specimen. The punch mark is used for measuring the extension using the vernier caliper. The punch marks are made at a distance of 2.5 d. So 2.5 into 12.9 is the diameter. So that is exactly at the 32.25 mm. Mark the second punch, and similarly you mark the other punches. So after marking these punches, you can measure the distances at the different places. And this is the universal testing machine. Now fix the specimen between the two jaws and apply the load. When you apply the load, it drag the specimen. Here you have the dial indicators, extensiometer, which measures the dimensions of the extension. So this is the machine. So after measuring the uh, so this is the dial indicators which are used to measure the length of the specimen. So just mark all the readings. When you draw the graph for the scale indicators versus load, you get a stress strain curve. And this is the plot of load versus extension meter. You can also download the data for the slope and measure the neck diameter. So this is the way how to measure the distance of extension. And tabulate using the formula, calculate the yield stress, tensile strength, modulus of elasticity, percentage elongation and percentage reduction in area. Thank you.